Hello, my name is María Virginia González. I am a doctoral student in Instituto de Ecología Regional, and through this little space that this conference gives me, I would like to talk about a study we did last year where we used big databases to understand how cities shape biodiversity patterns, especially those related to exotic plants introduction. Here are my co-authors. What's groundbreaking is we use global databases like the Global Biodiversity Information Facility or GBIF, which we hope bring us a new understanding of some process like urbanization and biological invasions. Let's have some context. From human activities, urban areas are the most dramatic land use change able to concentrate population, economic activity, and built environment, with entire landscape wholly created by humans. In this slide, we can see how urban ecology is linked with invasion biology through the introduction of plants. Also, these kind of studies can be seen through the perspective of a natural rural-urban gradient, where there are different environmental and socioeconomic drivers that will be modified through this gradient and have an implication in exotic plants distribution. Cities have roles as scenarios where humans bring plants and transport them through the movement of people, goods, and services. This is key to increase our understanding of exotic species dynamics in urban settings. Although modeling non-native species distribution along an urban gradient and considering its socio-environmental predictors constitutes an important approach, it remains relatively unexplored. So what's going on? Here is our study systems, the southern cone of South America, which includes Argentina, Chile, Paraguay, Uruguay, Bolivia, and southern Brazil. The area includes several ecoregions with biogeographic, economic, and cultural characteristics that result in a large environmental and socioeconomic diversity and a land use history that includes European colonization, which set the urban centers that persist to the present and were founded in different times. Also, it has a relatively little human modification during centuries, and it has the characteristic that during the last century it presented an accelerated urbanization that offered a suitable study system to explore how human activities influence exotic plants distribution. Here in its image, we can see how it changed nighttime light with our first sign of human activity from 2000 to 2020. It's what we can see in red and in yellow, that it's increasing through the last 2 decades. Our main objectives were to understand the socioeconomic and environmental drivers that model the proportion of exotic plants distribution, and also explain this process along the urbanization gradient in the southern cone of South America. So we estimate the spatial patterns of the proportion of these occurrences of exotic plants, evaluate different urbanization metrics, and evaluate the influence of these main predictors in the occurrence of the exotic plants along this urbanization gradient. Our main idea is that urban and productive areas constitute the introduction point of non-native species thanks to human activity and infrastructure that favor their dispersion. How we did it? This global collaborative biodiversity data rises as a challenge and opportunity. So we collected, as we can see in this image, occurrence data from Global Biodiversity Information Facility, or GBIF, estimated the proportion of exotic plants, and we compare this pattern through environmental and socioeconomic drivers. This association was tested using regressive modeling, and we also selected these socioeconomic and environmental drivers were climate conditions, native plant richness, foundation date of cities, land use diversity, cropland percentage, disurbanization gradient metrics, which we talked about already, and disturbances like fire. What are our main results? Is that first, one of our metrics was urban gravity, which was measured using population data and accessibility data, and it was an indirect metric of urban weight and the influence on its surroundings. So increasing urban gravity led to increasing exotic plants proportion. So this means that bigger cities with more connectivity are expected to increase its exotic plants pool because there is a more movement of people from and to distant places transporting and relocating these plants. Also, we see that cities are indeed hotspots of human activities that introduce new species, make environmental alterations which offer unique opportunities for these exotic plants through a unique combination. One of these characteristics is native species richness, and in the study we see that increasing native species richness have an effect in exotic plants proportion, and we see that in these urban settings, from a management perspective, increasing native richness can lead to reduced exotic plants proportion. So, what we believe is happening, or the main mechanism, is what we get from Elton's diversity invasibility theory, that species-rich communities are more resistant to invasion, meaning that native richness leads to resistance to biological invasions because they use the resources more efficiently and reduce this resource availability to an increasing resistance to invasion because these resources won't be used by exotic plants. So in cities, the change in the total diversity might also depend on a pool of native and exotic species, which is affected by human activity in an accidental or intentional way. Finally, our main conclusions is urbanization indeed increased the pool of exotic species through the movement of people and goods and services, creating these novel ecosystems that are built around humans. Also, modify its environment. Inside the city boundaries, there are better climate conditions, more stable environments, and reduced land use diversity that favor these exotic plants' presence. And outside the city boundaries, there are disturbance dynamics. This doesn't mean that urbanization increases invasion per se, just that cities change the pool of exotic native species. And these exotic plants appear to thrive in urban environments. Finally, we are in the emergence of big databases, especially in urban ecologies, and we are looking at them with increasing enthusiasm. Thank you for your attention. Thank you to my co-authors who helped me in the study, and I leave my contact here for any suggestions, comments, or any exchange of ideas. Thank you.